Okay, I think it's approximately 3:05 now. Let's start. Once again, good afternoon, everyone. A very warm welcome, and thank you for taking your time off to join us for this cybersecurity webinar. Together here with us today, we have from our partner, CYBERSECURITY by 5DX, Kawi, who is one of the cybersecurity instructors. And today we should be sharing on hiding data in unsuspecting files. Yeah. So I think without further ado, let me pass on the microphone to Kawi. Kawi, over to you.
Yep, thanks, James. So hello everyone, I'm Kawi, and today I'll be sharing more about some forensics processes in cybersecurity and some tricky ways that you can hide data within files. So this webinar is firstly brought to you by CYBERSECURITY, a global cyber education company that aims to spread digital skills and hands-on training needed to stay relevant in this constant technologically advanced world. And I'm Kawi, who will be the main speaker for today's webinar. And I'm a cybersecurity instructor at Thrive or CYBERSECURITY, and mainly specializes in penetration testing and application security with OSCP certification and 2 accredited CVEs. So with a steep rise in cyber attacks as the world becomes more technologically advanced, the need for cybersecurity is also rising. So more and more businesses are getting digitalized, thus increasing the attack surfaces that attackers can exploit maliciously. And the majority of the population on Earth has access to smart devices and the internet that holds critical information and drives our everyday lives. So furthermore, more functions are being automated and supported by technology, and even small downtimes resulting from cyber attacks for these servers can be detrimental. Hence, cybersecurity has now become a worldwide issue that has taken the media spotlight globally, being one of the main priorities for organizations looking to bring digitalization into their business processes. So according to research, 1 in every 99 emails are malicious, and this amounts to around 4.5 emails per employee. Furthermore, it's also reported that around 30% of such emails bypasses default security mechanisms, making their way to unsuspecting employees and even increasing the risk of falling victim to them. So some attributes this to COVID-19, where the US FBI reported a 300% increase in cybercrime. So because of this rise in attacks, the need for cybersecurity professionals is also increasing, with many organizations facing a skill shortage in cybersecurity, making cybersecurity one of the most sought after fields currently. But what exactly happens during a cyber attack? So let's try to understand the process of a cyber incident by looking into the cyber kill chain created by Lockheed Martin, which is a defensive framework used to aid in incident response and how to effectively mitigate and respond to threats based on the stages they are in. So for the cyber kill chain, it has 7 steps. So the first step would be reconnaissance, which is the information gathering stage. And this can include looking for email addresses to do phishing attacks, or looking through employee social media, or even looking at LinkedIn hiring posts to get an idea of a particular company's tech stack so that you can better plan your attacks. The next stage, we have weaponization, where you have already identified a vulnerability and starts to craft your payload, followed by delivery, which is how we are sending or executing our payload. So will it be through email? Will it be through a USB stick? Or maybe even XSS vulnerability on their own site? And then we have the next stage, which is exploitation. So once the payload is sent and executed, and then we have installation, which is once the payload has executed, we have gained access in the system, and then we start installing our backdoors, followed by the CNC phase, which is escalating privileges when we have access to our network and trying to pivot our way through to other internal subnets or network access or servers that are not publicly available. Then followed by our last, Sorry,
Kawi. Yeah, I think there's request for the slides to be presented to be bigger. Is it possible to make it bigger?
Let me see. It's a bit hard because
is this in the
I currently do not have my dual monitor set up.
Right. Okay. Okay.
Is it too small for the participants?
Yeah. It's a bit small. Normally, the presentation should be in PowerPoint.
Okay, give me a second. Let me see if I can connect this to my other PC.
Okay.
Okay, sorry guys, give me some time.
Yeah. So sorry for the inconvenience. I think right now we're trying to rectify the display screen. So just hang on for a while.
Is this better?
Yes, much better. Yeah, thanks, Kawi.
Okay. So all right, let's go back to where we left off. Sorry for the inconvenience. Let's see. Okay, so going back to the CyberQ chain, we have the 7 different phases, and we have the last phase, which is actions on objectives. So it's where attackers will conduct their initial objective for doing the attack in the first place. And this can either be exfiltrating data, using the exfiltrated data to conduct phishing attacks, or even selling them on the dark web. You can also inject ransomware to start blackmailing people, or even denying services to their customers. So once the incident is over and we go into the recovery stages, we start to look at any evidence and clues left behind to try to catch the attacker. But before we do that, let's jump into a physical crime scene to understand how it usually goes. So imagine you are an officer and you are going to a crime scene to process it. So what do you think would be the steps you would take to collect evidence? So anyone in the participants would like to try to maybe unmute yourself for a while and try to answer what you think a normal officer in a normal crime scene would do. Don't be shy, just unmute yourself. Collect evidence, yes, but before collecting evidence, what are things we do? Yes, take photos. That's part of the collecting evidence portion. Oh yes, surround the area, try to preserve the crime scene. Yeah, so I'm seeing a lot of answers and all of you are correct. So in a normal scenario, you would start with preserving the crime scene first to ensure no damage or modifications comes to the evidence on set. And then you start surveying and documenting any evidence like murder weapons or artifacts left by the perpetrator that will help in solving your case. So these can be things like check for CCTV, taking photos of evidence. However, what if it's a cybercrime? So similar to physical crime, digital crime also follows a step-by-step process to collect evidence that we call the digital chain of custody. So a chain of custody is a record of evidence documentation that begins with discovering evidence at the crime scene and ends with the completion of the investigation. So evidence should be handled carefully to maintain its integrity, so not being modified or tampered by anyone, and authenticity, and reflect the conditions in which it was discovered. So the scope of the chain of custody includes all individuals involved in the acquisition, collection, and analysis of evidence, as well as time records and contextual information, which can include labeling your cases, your units, and your labs that are processing the evidence. So the purpose of this entire chain of custody is to preserve the integrity of digital evidence and prevent it from contamination, which can alter the state of evidence and cause a crime or crime scene or case to go unsolved. So now we will look into some simple ways that information can be hidden within files to bypass detection. So the first one is through metadata, or what we call metadata forensics. So metadata is basically data-related information used for indexing and storage. So you can think of it like data describing other data, and it can be associated with a variety of file types, including photos, emails, office documents, and even audio files that contains fields like their title, their description, their text, their creator's name, and much more like date last change or file rights based on specific users. So this type of metadata attached to an online asset varies depending on how the asset was created or edited. So for example, metadata from a photo may include information like the type of camera used, whereas metadata from a book may include the name of the publisher and even copyright details. So in a sense, metadata is at the core of all digital objects, and it's essential for their maintenance, structure, and use. So metadata, when properly created and handled, contributes to information clarity and consistency. So it makes it easier to find important information as well as to search for and retrieve resources. So any digital object that has been tagged with metadata may be automatically linked to other related assets, making it easier to organize and discover. And it also enables users, particularly threat intelligence analysts, to make connections that would otherwise go unnoticed. So there are multiple ways to view the metadata of a file. So for a Windows user, you can simply right-click your file in File Explorer and go to its properties. But the information shown there is usually quite limited and not enough for the scope of a forensic analyst. So they use a more robust tool like EXIF2, like you see on the slide, to extract all metadata information about a particular file. So in the example image shown here, you can see that much more information about the target image is shown to the user. So this includes information that we don't usually need to know, like its EXIF version, its exposure program, or even its aperture value, etc. So in the eyes of an attacker, all of these fields can be used to hide important information that will go unnoticed by the average user. So let's look at a short demo on how to use EXIF tool. You guys can see the video. Yeah, if I full screen the video, can you guys see it? Okay, great. Okay, so let's look at a short demo on EXIF2. So any one of you guys with access to a computer can download EXIF2 for Windows or even Mac OS. And so in this demo, I prepared a simple image. It's called image01.jpg, as you can see here. And it's just a simple image showing a guy and some text, right? So what we're going to do is, firstly, the first way to view metadata in this image is simply like for Windows users, you can right-click the image, then you go to the properties window, then you go to the details tab, and there you can see a whole list of different data fields that is attached to this image. So in a way, it's data about the data itself. So that is one very simple way that anyone can do to access the metadata of a file. And you can do this not only on images, but any file in general. So even PDFs or Word documents. And then we have EXIF2. So what if we want to access more information, more metadata that maybe the Windows properties window itself doesn't show us? So you can use this very handy tool. And how you use it is that you can use it as an executable itself, but in this case, I'll be using its command line interface. So I'll be using the Windows CMD interface to interact with this tool. So what I do is basically I call the exif2.exe, and then I pass it the image o1.jpg as shown earlier. And you can see that now more information is shown, like your even I don't even know some of these fields because I'm not really that into photography, but you have stuff like color components, bits per sample, and etc. So all these to the regular user, you won't have much use for it, correct? But to an attacker or someone trying to hide information in files to detect to bypass detection, all these are data fields that they can hide information within it. So let's show how we can hide information with the same tool. So exif tool, since it's a CLI tool, command line interface tool, it also includes various arguments that we can use to attach data within the file. Let me see where it is. Yes, so in this case, we have this image. So we will use exif tools argument. So in this case, it's the -xmp, which is just a special argument that they use for this tool. And then we pass it the creator metadata field, and we attach a secret message string to it. Then we reference to the image. So if we run exif tool on the image again, after we run this argument with it, we can see that even though the image, if you open it up again, it looks exactly the same, right? It looks the same guy smiling with text. When you run it or you open it up in Windows properties window, you can see that the new secret message has been attached to this image. Yeah, so similarly, if we run it with exif tool again, you can see that you can also see the same secret message that is now embedded secretly within the image's metadata fields. So this is a short demo on viewing metadata information, or what we call metadata forensics. Okay, so let's move on. So other than metadata forensics, there are also a lot of multiple ways we can hide data within files. And the next one we're going to look at is steganography. So what is steganography? It is a technique for hiding tools or hiding files, within other files where the medium used is usually different from the file to hide. So the function of steganography is to use other media so that the confidential information in the original media is not visible. So the more valuable the information is, the more sophisticated the methods used to hide the data. And a wide range of file types can be used to hide data, ranging from even simple images or videos, or even Office documents or executables. And one of the most common methods to hide data within image files is through the least significant bit method. So let me just try to explain how this least significant bit method goes. So every digital image is made out of pixels, and each pixel has a different RGB value. So you can see this Mickey Mouse image here. Each pixel has different RGB values, and each the RGB values basically consist of 3 numbers from 0 to 255 that describes the color gradient across the red, green, and blue color planes that makes up a specific color. So in the first image, the RGB values are represented in a format called binary, which is basically ones and zeros that the computer can understand. And each character in this binary is called a bit. So this is a bit, this is a bit, this is a bit, and it has 8 bits in 1 byte, or in this particular binary string. So the least significant bit of this binary string is the bit on the rightmost of it, which is for this red value here is 1. Then we have the green, which is also 1. Then for blue, the least significant bit is 0. So how LSB works is that the secret message is first converted into a binary format, which is like that. And then each bit in the binary string is appended to each RGB value of an image, as shown in the second image. So since the difference between the original and the modified RGB values is very small, to the naked eye, you will not be able to see the difference between an unmodified image versus an image with a secret message hidden within it. So this sounds very complicated, but in reality, when we apply this LSB, it's usually done with tools, and it's quite straightforward, which I will now demonstrate to you guys again through a tool that we call OpenStego. So similarly, in this demo, I have 3 files now. Firstly, I have image02.jpg, which is also a very simple image with just a company logo. Then we have the secret.txt file, which just contains some gibberish or hi, I'm Kari, this is my secret message. And then we have another file called hello.pdf, which is just a simple PDF with a similar message included in it. So in this demo, we're going to be using this tool called OpenStego that similarly to Exif2, you guys can download it from the internet. So there are a few functions that comes with this tool. So firstly, we have the data hiding functions. So you can hide and extract data. Then we have also the digital watermarking functions that will not really look into it for this demo. So there are also a few options that comes with each function. So firstly, you have the message file, which is the file that we want to hide. Then we have the cover file, which is the innocently looking file that we want to hide data in, followed by the output stego file, which is the file which will contain the embedded hidden information, and some additional options like encrypting the data with an encryption algorithm followed by a password to further secure it. So for the first example, we'll try to hide the secret.txt file in the message file field. So we're going to include the secret.txt in this field, followed by our image2.jpg, which will be the file that we want to hide secret.txt in. And then we specify a final file that will include both secret.txt and image2.jpg. Then we basically click hide data, and this tool will do everything for us. So in reality, it can be more straightforward than manually doing the least significant bit algorithm ourselves. So it's going to generate a new file called hiddentxt.png. And when we open it, we'll see that it looks exactly the same as our previous file, which also shows the same logo. So what is happening in the background is that it's actually modifying each RGB value within the image. So since the difference between the original RGB value and the new RGB value with a hidden file inside is very small, since only 1 bit, so it's only a difference of 1, to our naked eyes, that difference in color is almost impossible to see. But in reality, it is just a slightly different. And you can see, other than the very, very slightly different color paints that is using, all other information, most other information within the file is different. Oh, sorry, it's the same. So to extract the data is also as straightforward. So you simply provide the stego file, which in this case is hiddentxt.png, and we provide the output folder to extract the contents from. Then we click extract data. You can see that the secret.txt that we have hidden in it in the first phase has been successfully extracted. But what if, okay, so right now the process to extract and hide data is very straightforward, right? We just input some fields, we just want to extract, we just press some buttons here. But what if we want to further obfuscate it so that not anyone can access our secret data, even if they found the stego file that we have used? So we can include some additional options like our encryption algorithm and our password. So the entire process is very similar. For this new example, I'll be including the hello.pdf as the secret file to embed using the same image2, but I'll be using an encryption algorithm now, specifically the AES 256 algorithm, followed by a password. Then I click hide data. So everything is the same, but additionally, now there are a few additional steps like encrypting the data with a password. So it's harder to extract. But in reality, the hidden PDF.png is going to look exactly the same as image2.jpg. Yeah, so extracting it will be similar. You just include the fields in the tool, and then you include the password. So if you don't include the password, it's going to say that it's corrupted or invalid, because since it's encrypted, it can no longer make sense of the hidden data within the file. So once you include the correct password, it will successfully extract the file, hello.pdf, within the same folder. And this is just a demonstration on how files can be hidden within other files. And yeah, so this is steganography. But of course, this only applies to image files, right? Since only mainly image files are the ones with RGB values, since it's basically made up of different colored pixels. But what if we want to do it from a different kind of file? So let's say an audio file. So to us, audio files are just files that make sound, right? So aside from hiding information within image files, you can also use audio files like MP3 or MP4 files as the main transmission medium. So how do we do this? We do this by using making use of the different signal strengths and amplitudes of audio signals to form messages. So in this case, in the image on the side, you can see that these different waves, they are basically signals and amplitudes, sound waves, to be more specific. And this can be done by synthesizing an image into a sound file and then opening it up into an audio editor software to view its spectrogram. So the main thing that we're going to use to hide data here is an audio file spectrogram. So what a spectrogram is, it's a visual graph of an audio signal's amplitude or loudness over time. So the image here is basically an example of a spectrogram. So the first one is what we see, the sound waves amplitude. Then the one below is its spectrogram, which is its amplitude or loudness over time, or in this case, frequency. So this another demo is, so similarly to the previous demos, we'll have a bitmap, which is similar to an image file that we are going to hide. It's called secret.bmp. So it's a simple image. It's just an image with a secret message that we want to hide. So how we're going to do this is we're going to use this tool, this image synthesizer called Coagula. So we're going to run it and a few windows are going to pop up. But the main one that we are going to be using is the one on the left. So the one with the black plane. And we'll start by opening our image within this tool. So which is a secret.bmp file. So what this tool can do is that it can render images into sound. So it do this using this button here. So in a way, for every sound file, there is going to be a graph of frequencies and amplitudes as shown previously, right? But what if we take an image literally as a sound graph or sound frequency and then render it as audio? So this is a kind of brief explanation of what this tool does. But if you like a better explanation, I think you should try to search up image synthesizers to have a better understanding of what it does. So in this case, it simply, let me see if I can play the audio. Sorry. Sorry, this is annotated over. Yeah, so you guys hear that? So if you take this image literally as a sound file, it's gonna sound very weird. Like generally what you hear, it sounds like crickets making noise at night, right? So this is one way to generate audio files from image files using synthesizers like that. So what we're gonna do is we're gonna save this sound as its own sound file. And now we'll go into extracting the string from this sound file. And what we're going to use is this audio analyzer tool called Audacity. And what Audacity can do, it can do a lot of different functions. So one function, the most important function that we want to look at is the function or the ability to view an audio file spectrogram. And that is just one possible areas that people can hide information within audio files. So just start by running Audacity. And we can open the file that we hid information within. So it's the secret.wab. And open it, it's just gonna look like a normal sound file, right? With like sound waves and the sound graph. But Audacity has the function to view its spectrogram. Oh, sorry, I forgot to build the video. Yeah, so you can do this by going to this button here. And then changing the view to spectrogram. And once I click, you can already see that it's starting to show, right, the secret image. So all we have to do is just tweak the options here and there. So in this case, if I'm not wrong, I'll be selecting the linear, viewing the string to linear, using the linear algorithm. Yeah, so once I selected the linear algorithm, it's already a lot more clear. And in a way, to recap, spectrograms are just an audio file's frequency over time. And this is another wacky way that we can use to hide information within files, specifically audio files. So this is a demo, and there are still a lot of other ways that you can hide files. So the next one I'm going to look at is through Office documents like PowerPoint and Word. So all of you guys here probably have a lot of, you guys probably work with Office documents daily, right? Since it's basically a must-have to work in any office setting. And little do you know that these documents can also be used to hide data. So this can specifically be done on second generation Office documents, also known as Office Open XML files. So these files are the one with the X behind the extension. So you have docx, we have pptx, we have even what is Excel called? XLSX. Yes, so these are actually zip archives, all of them, the way they're structured, even though they're Office documents, but in reality, they are all actually zip archives. So technically, by changing their extensions to zip and unzipping them, you'll be able to access all the files or assets included in these documents. And this makes it easy to check whether any hidden information or data exists in these files. But there is one thing to note, that this technique does not apply to first generation Office documents like doc and PPT. So it only applies to the newer ones with X at the back of its extensions. So similarly, with another demo, I have a file, a very normal looking PowerPoint slide, right? That there is actually a hidden file embedded somewhere in this PowerPoint slide. But since we're only opening up in PowerPoint, we can't really see it since it's hidden somewhere. It's just gonna look like a normal slide, right? But in reality, there's something hidden. So one way to extract or view all the different assets that are included in a docx or even XLSX document is to simply change its extension to zip, since they are all zip archives internally. Okay, let me fast forward this to the part where so we can start by doing this. We can start doing this by firstly enabling the ability to view extensions within our File Explorer. So in this case, in our File Explorer, all we do is we go to View tab, and then we enable this checkbox that says File Name Extensions, and then you can start seeing your .pptx or your .x extensions. So we simply just rename the file. In this case, I'm making a copy so that I don't overwrite the original file. And then we rename the extension. So over here, I rename the extension pptx and I rename it to zip. So now what it's going to do is that it's going to tell the computer that this is a zip file, and the computer is going to treat it like a zip file. So like any other zip files, you can start by extracting this archive. So in this case, I use 7-zip to extract the archive. And when you open it, you're going to see a whole different. So these are the different assets or folders that makes up a normal XML or Office document. And the folder that contains all external assets that people have included in such Office documents will be, if I'm not wrong, the PPT folder. And then you go under media and you can really start to see some additional images that you didn't really see in the original presentation. So in the original presentation, when we go in, we only see the first image, right, which is image 4. But now you see some other external assets that you didn't really see when you first opened it. And then we have embeddings, which is other objects. So in this case, we are seeing a .x and an XLSX. So why is an Excel sheet and a document doing in a PowerPoint slide? Is because it has been embedded somewhere within this PowerPoint slides. So through this method, by treating the entire document as a zip archive, we can simply unarchive it and start viewing all the special or hidden files that we don't really know is included. So you can even open them up. You can see that it's meant to be a secret document, right? Yeah, and this is a very simple way that even you guys as normal people who mingles a lot with such Office files can just start using by hiding information or maybe passing secret messages here and there in your workplace. Oh yeah. Okay, then we go to the last segment of this entire webinar, which I feel that a lot of you guys would be very interested is recovering deleted data. So aside from being able to extract secret hidden data in other files or artifacts, as a forensic analyst, it's very important to be able to retrieve important deleted data from evidence disks. So this is made possible because of the way the operating system deletes data. So when you delete the data, the operating system actually does not actually wipe the data, but rather removes the file's metadata. So recap, metadata is the data about a specific file. So this can be like the title, the description, etc. So it only wipes that file's metadata from the file table in that partition. So the way file explorers work is that for every file in your computer, they maintain a file table. So it's just like a directory of all the different files within that particular partition. So all it does when you click delete on your computer is that it just deletes the file row or the data row in that file table. So you can think of it like, you know, like removing a house location from Google Maps, but not the actual house. So you just can't find it in Google Maps. But if you go to the actual location, the house is still there. You're not really removing the house. You're just removing the location of the house. And similarly to computers, that's what you do when you right-click your file within the File Explorer, then you click delete. So basically, the data is still there, but its identification and location is lost. So it's still possible to recover deleted data by scanning the drive for file type identifiers, also known as their file headers, which is a unique sequence of bytes at the beginning of each file. that is unique to its file type, then we're storing them. But what do you do if you want to really delete a file and make it unrecoverable? So this is actually called wiping, and it's similar to deleting, but with some extra steps. So when deleting, to recap again, the file metadata is removed from the file table. So the space occupied by the file is still there because you didn't actually wipe the file. You merely remove the directions that the computer itself will know to locate the file. And the original data in that space is still kept. But when you wipe, it does the same thing as deleting, but with an extra step. So what it does is that the space originally taken by the file will be overwritten with junk and random values to prevent recovery. And this removes any remnants of file signatures and data, thus making it unrecoverable. So following the Google Map example earlier, aside from deleting the house location on Google Maps, in wiping, you also tear down the actual house. So let me demonstrate how you can recover data using this specific tool called PhotoRec that I feel that anyone, even you guys who are not forensic analysts, might find this very useful in the case that you accidentally delete data, but you didn't wipe it yet. So you can still use this tool to extract it or recover it. Yeah, so for this demo, I prepared an external drive. So what's special about PhotoRec is that it does this in partitions. So for every computer, you have a drive, main hard disk or main drive that you contain all your information in. So in that drive, it can contain different partitions. So in a way, it's like sectioning the drive into different parts. And this tool does it partition by partition. So you have to section, or it can only recover files from a particular partition, not a folder. So in this case, I created a new partition. So I'm going to name it the E drive, which you can see here in the File Explorer. And it will contain two different files. So the first one is hello.pdf, and the second one is a JPEG, a secret image JPEG. So yeah, I created a new partition here, separate from the C drive. Yeah, so going back to the files, hello.pdf is just a very simple file with nothing to see here. And then secret image.jpg. Let's see. Secret image.jpg is just another normal looking image with text and a black background. So what I'm going to do is that I'm going to go ahead and delete both of them. So if you just do this, technically there's another way that you can recover it. It just goes to your recycle bin, right? In Windows. So I'm going to remove it from the recycle bin too. Yeah, so go into the recycling bin and I'm gonna permanently delete those files. So in this case, to the normal user, those files, like, you're gonna think that it's unrecoverable, it's completely deleted, but that's not actually the case, because all you've done is just remove the location or the way to find that file, but you didn't actually remove the actual file content from your computer. So we'll go ahead and open up this very handy tool called PhotoRec, which is under another tool called Test Disk. So similarly to Exit tool, it's a command line interface tool. So it's going to open up in your CMD. And what you do is you just select options. So in this case, okay, let me fast forward a bit. Yeah, so in this case, I'll be selecting the particular disk that I created a partition in. So this will be disk 1. I'll select it, and then I select the particular partition that I created just for this demo, which is called test. So it's this one. and you select the file system. So for Windows devices, you'll be using the NT file system. For Mac OS, you'll be using hierarchical file system, which is HFS+, but both of them are in the same option, so you're going to select them anyways. Oh, but to add on, if you're doing this from an external drive, usually external drive uses an external file system, which is ext 2, 3, or 4. So you might be selecting that instead, or it can also use FAT. So it depends on what file system that you'll be using. And then finally, you select where you're going to extract all the information from. So in this case, I'll be selecting the recovered folder that I created. So once it runs, it's quite fast since the data isn't really deleted. So you can see that it has successfully recovered 2 different files, which matches up with the 2 different files that I deleted just now. And then we'll go ahead and try to open up those 2 files recovered. See that one of them is a PDF file and one is a JPEG file. And we have successfully recovered those 2 files, even though, like I demonstrated earlier within this video, it was deleted and even permanently deleted from the recycling bin. So to go back to recap what happened. So remember that I deleted the 2 files from this drive E, right? I deleted it. But what actually happened is that the space taken up by these 2 files within this drive E was not actually wiped. So you just deleted the way to locate that file. So if you want to really permanently delete it, so that's what we call wiping. What we're gonna do is that you're gonna rewrite new files into this area after you delete the files. So once you rewrite new files, the computer is going to take that original space occupied by the original file, and it's gonna write new contents into it to fit the new file. And that's how you really wipe something out. Can this application Photorec use to recover data from mobile phone? If I'm not wrong, yes, because you have to do a bit-by-bit copy of your partition in your phone into an external drive or a partition or basically a drive that the computer can read. Then once you have that bit-by-bit copy, you can start trying to recover the file. I'm not sure NTUC LearningHub will be sharing these videos, but it'd be great if they can share it. Then you guys can relook at how I did the demos and even hear my annotations within demos. Yeah, so this is a quick demo on how there is a difference between deleting and wiping and how you can recover files with a tool called Photorec. But make sure when you delete a file, you do not write new files into it, because that's going to mess up the entire process. It's going to rewrite data into the original data that you want to recover from. And this is actually the last demo in my webinar. So this brings me to the end of my webinar. I hope it gives you some nice insights and techniques on different special ways that you can hide and retrieve secret data in suspicious files. So do note that in real life scenarios, there are probably more sophisticated methods and techniques used to further bypass detection. And these examples that are shown are actually quite simple and straightforward. And it's made to be more, to be better understood by other people and to learn from it. So even so, I hope it was interesting, and you can feel free to ask questions in the Q&A. So let me see some questions. Do I need formal computer science qualifications to join this field? What about those of us with very good degrees in other disciplines and have done cybersecurity related programming on our own? I would say a formal education would be great, though I know a lot of different red teaming specialists other cybersecurity specialists who do not have a degree, but they are still able to join the field. So what's most important is the ability to self-learn, because in cybersecurity, a lot of different new tools, a lot of different new attacks are happening every day, right? So even if you have formal education, in a matter of around maybe 2 to 3 years, it's going to be obsolete because there's already new ways to attack. There's already new tools that are coming that your formal education that you took a few years back isn't going to cover. So the most important thing is continuously learning and improving yourself in this field. And that's what really sets apart those that really succeed in cybersecurity and those that do not. So are antivirus software able to catch these hidden data? No, they do not, unless the data that you hide is malware itself. So there are a few ways that antivirus, there are a few techniques that antivirus software use to try to identify particular malicious software. So one way is through signature detection. So online, there is this website called VirusTotal. And what it does is that it maintains a database of known malware, and they do this using the malware hash. So each file, there is a way to extract or generate a particular file hash from each file in order to identify it. And that hash will be unique to the particular file. So it maintains a database of all these known malicious files. And one way that antivirus software can use to hide or use to detect whether a particular file is known to be malicious is through these file hashes. So unless that data is already malicious itself, then it will probably be flagged. There is a chance for it to flag if you use these simple methods to hide it. Otherwise, if it's just a simple message or like a simple string that you just use to hide data, it's not going to detect them, since it doesn't know if the data or if the string or the simple image file or PDF itself is malicious. Does factory reset is the same as wiping or just deleting? If I'm not wrong, factory reset would be wiping the data. Since in some factory resets, you basically reinstall the operating system, right? So when you reinstall the operating system, you remove the old operating system, and then you install the new one. So technically, you are overwriting the data in it. Yes. So another question that people ask. How to hide a file in PPTX? Okay, so earlier I showed ways to extract files in PPTX. Right? It's just simply treating it as a zip archive, and then you just unarchive it to view all the files. But to hide a file is as simple as maybe embedding another file within the PPTX. So there's an insert function in your PowerPoint interface, right? So you just embed a file and maybe you hide it somewhere that is not in the site itself. So that's a very straightforward, simple way. So in a way, people who don't spend a lot of time looking around in that site or looking around at embedded objects is going to miss it. And that's a very straightforward way you can use to hide files in PPTX. For delete data, is it same for Windows and Mac OS, which means remove metadata? For Windows, yes, removing metadata. For Mac OS, to be honest, I'm not that sure. So you'll probably have to try to look that up on your own, but I think it is similar. Data from storage media that has become raw format. And what about disks that have been formatted? Is the same as wiping data? Yeah, when you format a disk, that is wiping because it overwrites data within it. If it's raw format, it is still recoverable as long as you do not overwrite the bit. So if you go really, really deep into how computers look at data, they look at it in binary. So everything that you see on a computer, every file is just a string of ones and zeros. Or quick format does not wipe data. Interesting. Yeah, so it's just ones and zeros. So as long as you do not overwrite that, technically it should still be recoverable. Let me see. These software tools used in this are open, and how secure are they for us to use it? There is a common misconception in open source tools and proprietary tools. So proprietary tools are closed source tools, are tools where organizations have created and they did not open the source code for everyone to see. So there's a common misconception. Open source tools are usually more vulnerable because everyone can see the source code, right? Everyone can try to take it apart and see if there's any vulnerabilities within it. But at the same time, it also is able to leverage on the community to try to find those vulnerabilities. So in a way, yes, in a way it makes it more open, but on the other hand, it also gives more opportunity for the community, cybersecurity community, to identify those vulnerabilities before an attacker does and fix it before they start to exploit it. So I wouldn't say that open source tools are always guaranteed to be more vulnerable than closed source tools. Some of them, like for example, the Linux operating system is an open source operating system, but it's not as vulnerable as some other operating systems. And one reason is because it leverages on the open source community to try to constantly verify and secure its source code and fix any outstanding vulnerabilities. Yeah, definitely. Every operating system has its own flaws. Hackers can insert into open source codes too. There's actually a very interesting case study that happened recently is by using open npm packages to try to inject malicious code into their services. So in Node.js, a lot of different services references open source packages or online packages that are found in the npm database. And what attackers did was that they created their own malicious packages on the npm databases, and then they try to name it similarly to other known packages that a lot of people use, or they even write directly to that package and include malicious code. And organizations end up referencing that packages and using it in their code, making it vulnerable. Valid case studies. Case study. Yes, I've said.
Sorry, Gauri.
Yes.
Yeah, I pause for a while for the Q&A.
Oh yeah, sure.
Let us take the attendees through the course fee and also the schedules for the CYBERSECURITY courses. So let me quickly just share the screen. And thank you very much for the presentation.
Oh yeah, I hope it was interesting to you guys.
Definitely
Thanks,
very interesting. We just paused for a while for the Q&A. So I just wanted to share with everyone that for CYBERSECURITY, we have two courses. One is the CSPC and the other one is CBFP. CSPC is actually the level 1 course. So if you guys have not taken cybersecurity awareness courses and you want to know what cybersecurity, this is the must-have course, which is the first course you should take. And also, if let's say if you have already taken the CSPC, you can move on to take the CBFP. For the CSPC, pretty much is the cybersecurity awareness. Okay, and this is IBF funded. The cost fee for the CSPC is $400 before funding. So between now till 2nd of October, there's a 90% funding for this course for Singaporeans above 40 years old. And if you are below 40, then it's 70%. Okay. So the next course is CBFP. This is the Cybersecurity Essentials for businesses. It's also a one-day course, and it's also IBF funded. Full course fee is $800. And from now till 2nd October, there's the funding available for both Singaporeans and PRs aged below 40, which is 70%. And if you're aged above 40, it's 90%. So there we have the website available for you to look at the more in details what to expect for the one-day course for both courses. If you want to reserve a spot, you can go in to click reserve a spot, and then once you click on reserve a spot, you can register yourself as a self-sponsored individual or as a company-sponsored trainee. Yeah, so also like to share with you this. So this is the QR code for both the course web page, and also you can contact our consumer sales team here. We have Joel and Kenneth in the call. If you guys are interested, feel free to contact Joel. Meanwhile, let's continue to go ahead to finish up the rest of the Q&A. Over to you, Kawi. Thanks.
Oh yeah, I'm actually answering some answers by typing it out because I feel that it's easier to do that. Give me a second.
So I think some of you have requested for this video to be made available. We will check back internally with our marketing team, and we will see if we can post this on our social medias. But of course, after this webinar, we will be able to share the PowerPoint slides that Kawi has presented. Okay, we have a question from Anonymous. Any age limit to taking up cybersecurity? Can retirees take it as a second career? Kawi, have you answered this question yet? Not yet.
Yeah, I don't think so. Which question is? There are quite a few questions actually.
Yeah, there's one question on any age limit on taking up cybersecurity.
Cybersecurity. Definitely no. As long as you're passionate about cybersecurity and you're willing to continuously learn and upskill yourself, then I think anyone can get into cybersecurity. So retirees can definitely take it as a second career. And a lot of people always, when they hear cybersecurity, they think like, oh, it's gonna be about hacking, it's gonna be about trying to exploit other people, but that's not always the case. So there are other aspects of cybersecurity that retirees or even other people can look into. So those are more on the blue teaming and DevSecOps side. So you have stuff like malware analysis, you have stuff like incident response, you have stuff like threat detection, and you even have things like cloud security that is becoming more of the in thing nowadays, since a lot of different organizations are looking to implement their services on the cloud. So there are a lot of different aspects of cybersecurity that you can definitely look into, and you can start to try to involve yourself in it and possibly look at it as a second career. So there's one question: why would the person hide files or data? So there are a lot of reasons that a person can have to hide files or data. So they can do it for fun. They can do it maybe to hide evidence of a crime that they have created. So there are a lot of different reasons, but as forensic analysts, the most important thing is being to identify key areas where a person can or might have hide or hidden secret data or files and extracting them. Can hackers hide malicious files in image or sound files? Yes, definitely. Like I demonstrated just now, using spectrograms in sound files, or using steganography tools, or even algorithms like least significant bit. Will the secret message inside the image be lost if we upload the image into social media? So social media will recompress the image, right? Yes, I'm pretty sure that there is some data loss from compression. Applications like Instagram is known to either compress the image into a low resolution so that it will take up lesser traffic, or it will resize the image to fit their image dimensions, which is 1:1 aspect ratio. So similarly, it's also similar when you export a PNG into a JPEG. So the difference between JPEGs and PNGs is that PNG has an extra, one of the main differences is that PNGs have an extra alpha channel, and the alpha channel controls the opacity, or opacity as in like how transparent, in a way, how transparent the image is. So by exporting a PNG into a JPEG who does not have such alpha channel, so they have, in a way, they hold lesser information about an image, you can also end up losing data, some amount of data in the image, even though when you open it up, it still looks the same. So it's a very similar concept. Yes. Like Boon, yeah, like someone in chat said. Where can I see this video again? How to hide data? Same as wiping. The deleted data is forever sit in the computer unless it is formatted. If you do not rewrite new data in it, then yes. When you delete a file, it does not actually rewrite or scramble the data within that particular original space taken by the file itself. Wrong. No, delete. Okay, so someone asked, so deleting data will not really free up disk space. It does free up disk space, but what it does is that it's gonna tell your, okay, so your computer maintains a file table, and in this file table is a directory of all the files that it knows exist on the file system. So when you delete a data, it's just gonna remove, it's just gonna tell the computer that, okay, so this file and this file table does not exist anymore. And by knowing that, the computer will make that space that was originally taken up by the file available for new files to be written to. So in a way, you are freeing up this space that can be written to. But if you do not write anything into that original space that the file has taken up, technically the original content is still there to be able to be extracted and made sense of. How to know the location of the data? So going back to how operating systems maintain a directory of all the files, they do this through a file table. So if I'm not wrong, for Windows file systems, they call it the master file table, the MFT. Though I'm not sure if the other file systems used by Mac OS and Linux is similar. Maybe they give it a different name. Does data wiping happen automatically when the computer is very short on storage space? No. No. I'm sure, oh, the question is gone. Will defragmenting the disk achieve the same outcome of wiping the disk? That's a very good question. Honestly, I'm not that sure. So I'll probably have to look that up again. So I'm not sure what if it will really wipe the disk. But what a lot of organizations do is that nowadays when you pass a tool function to do in your disk, right, you don't really know if it's really doing the expected function that you want it to do unless you reverse engineer it, you open it up and reverse engineering. So for organizations that really value data protection, what they do is that they just straight up destroy the drive. So that's a very surefire way of knowing that your data is going to be safe and nobody's going to be able to extract anything out of it.
Kawi, I just want to answer one of the questions from Francis. I think she's asked whether the courses are conducted through Zoom. Answer is yes. For the both course, one-day courses, both are conducted via Zoom.
What's the difference between a low-level and high-level format of a hard disk or flash drive? I don't really understand what you're trying to ask here. There is levels. Maybe if it's okay, if you're still in the chat, maybe you can further elaborate on what you mean by that. Okay, another question. Does wiping of deleted data happen automatically when the computer is very short on storage? Again, no. All it's going to do is for some computers, they're going to use, if I'm not wrong, I might be wrong, they're going to use temporary storage to temporarily store that data if they really run out of space. So there's a few ways that can happen if it runs out of space. It's gonna crash, like your particular application is not gonna write needed information that it needs to continue functioning, so it's gonna crash. Or the computer is gonna use RAM, their own temporary memory, maybe the RAM, to store that information temporarily. But what it's going to do is that it's going to be slower and it's going to start to lag. So yeah, but it will not wipe. Oh, wiping of deleted data. Sorry, I misread it. Wiping of deleted data, not wiping of data. So in a way, deleted data is already known to not exist by your computer. So in a way, it's definitely going to overwrite that space that was once taken by deleted data. So yes, the answer would be yes. Okay, so that's it for the questions. It's been a really interesting session with you guys. There was a lot of very elaborate questions, interesting questions, and even also some hard questions, but I had a fun time answering all of them, and it makes me happy to know that a lot of you guys are very interested and found it useful. So if you'd like, definitely check out for more LHub webinars, and I wish you all the best on your journey in cybersecurity. So James, back to you.
Yeah,
thank you
thanks
so
a lot,
much.
Kawi. I think we had quite a good session today. Very good turnout, and I see that some of you are already wanting to register for the 2 courses. If you're interested, please contact Joel. His WhatsApp number is shown on display. Or alternatively, you can actually email to Joel or Kenneth. We have the 2 QR codes where you can use whip up your mobile phone to scan, and it will lead you to our the 2 course page. So we'll pause here for maybe a few seconds, And if there's no further questions, we can call it a day. Thank you, Anonymous, saying that this is an eye-opening webinar. We will have our consultants contact you with regards to the deck that was shared in this webinar. And then with regards to the video, we will check in again with our marketing team if it will be posted on social media. Okay, so once again, do not hesitate to contact Joel or Kenneth with regards to the two cybersecurity courses. Both are one-day courses, very good courses if, let's say, you want to learn more about cybersecurity. We have one comment by Alan saying that if the course is taught by Kawe, it will be even better. Yes, definitely, we will like to invite Kawe to be our trainer. Okay, I think that's all for today. Thank you very much, and have a good week ahead.
Thank you.
Thank you.
Bye-bye.
Bye-bye.